Good day everyone. Welcome to all. My name is Sachin Ahankari. I am working as assistant professor in NRCM Engineering College, ECE department. So today in this session we will study about the basic information of op-amp. We will continue with the basic information of op-amp. So we have seen that op-amp is a direct coupled high gain amplifier, and it is consisting of various stages of differential amplifier, and it is followed by level translator circuit and output stage. So gain provided by the amplifier is uh, very much large. Open loop voltage gain, the large in the sense the practical value of open loop voltage gain is 2 into 10 to the power 5 or 1 into 10 to the power 5. So it is a minimum open loop voltage gain provided by your op amp. So here we will see the different modes of op amp. In three modes the op amp can be operated. The first mode is single ended mode. In the single ended mode of operation, you are applying the input voltage either to the inverting input terminal or to the non-inverting input terminal. If you apply the signal to the inverting input terminal, then non-inverting input terminal is grounded, and if you apply the signal to the non-inverting inverting input terminal, then non-inverting input terminal is grounded. So here uh, one of the input terminal you are applying the input signal, and the other input terminal is grounded here. So if you apply to the non-inverting input terminal, inverting is grounded. If you apply to the inverting input terminal, non-inverting is grounded. So in that fashion the single ended mode is operated. So here if you apply to the inverting input terminal and non-inverting input terminal is grounded, then here it is applied to the inverting input terminal and non-inverting is grounded. If you apply it to the inverting input terminal, your output voltage is 180 degree out of phase with your input voltage, and if you apply it to the non-inverting input terminal and inverting is grounded, then at that time your output voltage amplified input voltage or output voltage is in phase with the input voltage. So this is going to happen in the single ended mode. If you go for the double ended mode or differential mode, double ended mode is also called as a differential mode. In the differential mode of operation, you are applying the voltages to both the input terminals, that is to the inverting input terminal as well as to the non-inverting input terminal. The voltages are not equal generally, and this is called as a and the difference between these two voltages is taken out. So if V1 is applied to the non-inverting input terminal, and if V2 is applied to the inverting input terminal, then non-inverting input terminal voltage minus inverting input terminal voltage is taken as differential voltage. You are not going to take the inverting terminal voltage minus non-inverting input terminal voltage. Always keep in mind that the differential input voltage is a non-inverting terminal voltage minus inverting terminal voltage. So this is a differential input voltage uh, is applied to the op amp, and the output is proportional to the differential input voltage. So the V0 is directly proportional to the VID or VD. VD is a difference voltage, or VID is also a difference voltage. So if I am consider it as VD, then V0 is directly proportional to the VD. And if you remove the proportionality constant, then V0 is equal to AD into VD. So AD is a proportionality constant, and it is a differential gain of the op amp. So V0 is directly proportional to the Vd in the differential mode of operation. So V0 is equal to Ad into Vd in the differential mode of operation. And if you go here for the common mode operation, in the common mode operation, the same input voltage is applied to the inverting as well as non-inverting input terminal of op-amp. The same input voltage is applied, and here if you are applying the same input voltage, the VID is equal to 0, and since VID is equal to 0, the output voltage should be ideally 0. So in the common mode configuration, the output voltage should be 0 ideally, but practically there exists some voltage, even though the you are applying the common signal to the inverting as well as you are applying common signal to the inverting as well as to the non-inverting input terminal. There exists some voltage, and it is an amplification of your common mode voltage, and this common mode voltage is the average of this V1 plus V2 divided by 2. So here it is taken as an average voltage, and common mode voltage is the average voltage, and this common mode voltage is generally, it is an interference. I will show you one slide here. So generally the common mode signal is an interference or it is a noise signal. So it is generally, it is a, so common mode signal is a interference or a static or other kind of undesirable pickup or a noise. So these are the common mode signals: interference, static, and other kinds of undesirable pickup. So this common mode signal is amplified by the amplifier, and some voltage is available even though your VID is 0. So practically some voltage is available, and that V0 is directly proportional to your VC. VC is nothing but common mode signal. And if you remove the proportionality constant there, so if you are going to remove the proportionality constant, then at that time you are going to apply the V0 is equal to, V0 is directly proportional to VC, that is V0 is equal to AC into VC. So AC into VC, so here V0 is directly proportional to the VC, that is common mode voltage, and common mode voltage is average voltage of this one, and common mode voltage is a static or interference pickup done by the, or it is a noise created by the other power supplies, and it is amplified, and the output voltage is directly proportional to the common mode voltage, and V0 is equal to, if you remove the proportionality constant, V0 is equal to AC into VC. So here V0 is equal to AD into VD, and here V0 is equal to AC into VC. So generally the noise is always there in the uh, which is associated with each of the terminal. So whatever the noise is there, so output voltage is not only dependent on the differential input voltage, but it is also dependent on the common mode voltage also. So the output voltage is equal to AD VD plus AC VC practically, and ideally this AC VC should be, this term should be 0 ideally, then your amplifier is acting as a perfect differential amplifier, but practically it is not going to become 0, it is having some value over there. So this is about your differential common mode and single ended mode. So these are the three types of modes which we have studied here. We will go for the transfer characteristics. The transfer characteristics is the graph between the output voltage and the differential input voltage. So output voltage is taken on the y-axis and the differential input voltage is taken on the x-axis. So here whenever the op-amp is in open loop configuration, whenever the op-amp is in open loop configuration means we are not applying any kind of feedback over there. So whenever op-amp is in open loop configuration, then at that time uh, what is the input voltage it is going to amplify, we are interested to see. So here uh, the ideal characteristics of op-amp, ideal transfer characteristics are in this fashion, and the practical characteristics are in this fashion. Also, in linear region only, it is acting as an amplifier, and here in the saturation region, it is not acting as an amplifier. So, what is the voltage range for which it is acting as a amplifier? We are interested to see. So whenever the op-amp is in open loop configuration, uh, then at that time uh, here, as you are going to increase the uh, differential input voltage, as you are going to increase the differential input voltage in the positive direction, that is when VID is positive, as you are increasing it up to some extent, it is increasing linearly, and after that it is going to saturate. So here the input voltage uh, range must be so as we know that V naught is equal to AD into VD, AD into VD. So VD is nothing but this is on x-axis, VD is on x-axis. So here V naught is equal to AD into VD. So VD is equal to V naught divided by AD. So AD is open loop voltage gain, which is 2 into 10 to the power 5. So if you are applying the supply voltages of 15 volt here, if you apply the supply voltages of 15 volt minus 15 volt, then your output voltage uh, will not go above 15 volt. So this is a law of physics that the output voltage, amplified output voltage, will not exceed the battery voltage or DC supply voltage. If it is going to exceed the DC supply voltage, it is going to violate the law of physics. So therefore your output voltage is in between the DC supply voltage, even though you are amplifying it. So here if you are applying 15 volt, then the output voltage, you know that it is maximum output voltage is 15 volt. So V naught is 15 divided by AD is 2 into 10 to the power 5, and the voltage range, the input voltage range or differential input voltage uh, which can be amplified is given by 7.5 75. So 15 divided by 2 is 7.5 and 0.075. So 0.075 microvolt will be the range here. If you give 12 volts here, and if you consider the open loop voltage gain as a 10 to the power 5, then the 12 divided by 10 to the power 5 will be the input voltage. That is 12 divided by 10 to the power 5 is 12 into 10 to the power minus 5 and 1.2 microvolt. So here the voltage range is 1.2 microvolt. So from 0 to 1.2 microvolt, it will increase linearly. After VID is greater than 1.2 microvolt, it is going to be saturated. Similar is the case here in the uh, negative part. That is, if you go here for the negative part, it is minus 1.2 microvolt in that fashion. So very less differential voltage is amplified by the open loop configuration of your amplifier from 0 to maximum of 75 microvolt or 100 microvolt, max 300 microvolt, depending on the output voltage and depending on the open loop gain of the amplifier, you are going to get the range of input voltage which you can amplify in the open loop configuration. So here we are going to stop some other basics of op-amp and some characteristics of op-amp we will see in the next lecture. Thank you.